Hi class. In this lecture here, we want to finish talking about hypothesis testing for two samples when talking about hypothesis testing for two proportions. And so the good news about this one is there's only one way to do this test. We don't have to worry about independent samples or paired samples. There's just only going to be one option in your calculator. And if you go to your calculator, and if we go to stats, tests here, it's actually just, how when we first introduced this topic, we were doing option number 4, 2-sample t-test here, 2-prob z-test. What we were using when we had one sample proportion was 1-prob z-test. Here, we're just going to focus on option number 6 in our graphing calculator. All right, so I'm actually going to set this up with an example. And so, does it seem like every issue facing America today is very, very political? It's like we can't agree on anything, depending on which political party you belong to. So it doesn't seem like political parties can agree on anything. But what about the gas tax? So what I mean, here's a question for you to consider. So a survey recently asked individuals if the gas tax should be eliminated for the summer months. So, most people drive more in the summer, so it would just make, driving cheaper, okay? So do you think there is a difference in how Democrats and Republicans would respond to this? I don't know. Maybe not, or maybe both of them would say, yeah, we should eliminate it, or maybe both of them say we should keep it. But we just want to see. We're not saying which one would be more likely to say we should get rid of it. We're not saying that. What we're just asking is there a difference between the two proportions, okay? The proportion of people who say we should eliminate it among Democrats and the proportion of people who say we should eliminate it to Republicans. Is there a difference? All right, so how would we test this? All right, well, guess what? We're going to do the same 3 tests. There's just different notation. That's all. So what we're going to do here is we're going to define the parameters. We're going to let P1 be equal to the population proportion represented by sample 1. So whatever our first sample is. And then we're going to let P2 be equal to the population proportion represented by sample 2. And what we're going to do here is we're going to run a two-tailed test. This is actually what our first one's going to be. We want to see if there's a difference. Then we're going to run a left-tailed test. And then finally a right-tailed test. And so again, as with all hypothesis testing, we'll start with a null hypothesis and an alternative. And we'll always start with a statement of equality that P1 is equal to P2. And here with the two-tailed test is we want to test to see no way they're different. Left-tailed tests our null will be that P1 is equal to P2. Those proportions are the same. And the alternative here, we're going to look to say, no way. P1 is less than P2. Null here for right-tailed test, P1 is equal to P2. Always start with the assumption of equality. And our alternative here would be like, no way, P1 is definitely greater. It's got to be greater than P2. Okay. So look, notation is slightly different, and what we're going to input in our calculators are going to be a little different, but as always, we're going to rely very, very heavily on our graphing calculator for this. So then again, we're going to go through the 5 steps, okay? So what we're going to do here is we're going to perform a hypothesis test, compare two populations proportion, P1 and P2. Assumptions, simple random samples, independent samples, and then these are just some number checks. This is just to verify you have sufficient sample sizes. For our problems, we'll always assume we meet the I'll always give problems such that the sample size is sufficient. All right. Step 1, set up the test. Again, null, statement of equality, then two-tailed, left-tailed, or right-tailed alternative. Level of significance for us, generally I'm always going to give you 0.05, or every once in a while I might try to sneak in at 0.01. Then what you're going to do is you're going to compute the test statistic. All right. Here it's P sub 1 hat minus P sub 2 hat divided by this crazy formula here. All right. I'm not going to spend a lot of time getting into this, but this is going to be our test statistic, Z sub 0. And we're going to let the calculator do this for us. All right, why not let it when we can? Step 4, you're going to do the p-value. Again, TI calculator will do this for us. And you'll see how quickly this is done when we go in the calculator. And then finally, if the p-value is less than the level of significance, reject the null. Otherwise, if the p-value is greater than the level of significance, we fail to reject the null. Okay. As always, I don't know if you've all noticed this as we've gone through these tests, but once you get through step 1 and correctly define the 2 parameters and set up the test, going to the calculator, it kind of just goes boom, 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 boom. All right. Well, anyways, let's jump in and do this. All right, so a recent survey from Quinnipiac University Poll, which conducts nationwide survey as a public service and for research, asked participants whether they thought eliminating the federal gas tax for the summer months was a good idea. All right, so sample 1 is the Republicans. And what we saw here, that their p hat sub 1, of 611 Republicans, 275 thought it was a good idea. So look, if you just calculate the p hat real quick, it's around 45%. Sample 2 is the Democrats. And their p hat, we'll call p hat 2. There were 872 Democrats in the poll, and 366 of them said, yeah, it's a good idea. So that p hat it's a little bit lower. I'm going to round it off to 42%. Okay. All right, so what looks like there's the three percentage point difference. Okay, all right. So is that difference statistically significant? All right, let's find out. At the 0.05 level of significance, can you conclude there is a difference in the proportion between Republicans and Democrats who think eliminating the gas tax during the summer months is a good idea? All right. So look, difference going to be two-tailed test. Let's go through the 5 steps. I'm going to set up the test. So we're going to let P1 equal the proportion of Republicans. I'm just going to put REP for Republicans here, who think eliminating during summer months is a good idea. I'm just going to say eliminating gas tax is a good idea, but we will know that this means just during the summer months. And we're going to let P2 be the proportion of Democrats. I'm just going to put DEM, who think eliminating the gas tax is a good idea. And so we just want to see if there's indeed a difference. Okay, if there is indeed a difference between them. So our null will be that P1 is equal to P2, and our alternative will be that no, there's a difference. They're not equal. Level of significance 0.05. So test statistic, we're going to have the calculator find for us, and it's also going to report the p-value. So when I go to load up my calculator for this, I'm going to go stat tests And I'm going to go scroll down to option number 6, this 2-prop z test. Okay. And so let me even go put that back in the notes here. So we use stat, tests, and then it was option number 6. 2-prop z test. And so when I hit enter, you're going to notice it's going to ask me for a few things. So X sub 1 was the Republicans. Okay, so 275 Republicans thought it was a good idea out of the 611 total Republicans. And then look, X sub 2 was 366. And there were 872 Republicans. And we just wanted to check the alternative was, going back, that they were not equal. So I'm going to make sure that's selected. I'm going to scroll down to calculate. You can see there's a lot of information here. You can see it actually calculates p hat 1 and p hat 2 for you as I did. But it's saying the test statistic is 1.1615. And the p-value here is 0.2454. So guess what? You failed to reject the null. Right, this is because the p-value is greater than the level of significance. So look, you know, even though everything is political, what we're saying is evidence does not suggest. So even though the p-hats were different by 3 percentage points, it wasn't enough. Does not suggest there's a difference in the proportions. It's like we found the one thing that Republicans and Democrats can agree on. All right, at least it's the proportion that I think it's a good idea for eliminating the gas tax during the summer months. All right, so hopefully, this one was a little bit easier with the calculator to set up. All right, let's try one last one here. We'll only do 2 examples for this one. All right, so this was more on medical research here. So a recent study was published that performed a comparison of 2 drugs. Okay, I'm not going to try to pronounce them here. We'll just call this one drug C, and this one was drug T. Okay. And both of these drugs are designed to reduce the risk of heart attack or stroke in coronary patients. So our sample 1 will be drug C. And sample 2 will be drug T. All right, so p hat 1. There were 6,676 patients who took this drug. And of those patients taking this drug C, 668 suffered a heart or stroke attack within 1 year. Okay. So it looks like this one was about 10%. Sample 2, right, using drug T, there were 6,732, and 569 of them experienced a heart attack or stroke within the first year. So a little different here. 0.08. Here it'll be 5 when I round it. All right, so pretty close, All right, but anyways, can you conclude that the proportion of patients suffering a heart attack or stroke is less for those taking this second drug? Okay, so right here, this is what we're testing. And here we want to switch it up and use the 0.01 level of significance. Okay? Notice that this is only a 1.5 percentage point difference, but look at how large the sample sizes are. I mean, that's going to be a big factor here. Okay, so it's about people who suffered a heart attack or stroke within 1 year on these drugs. So here's how we're going to set up the test. We're going to let P sub 1 equal the proportion who stroke. I'm going to put HA for heart attack within 1 year on drug C. And P sub 2 is going to be the proportion who have a stroke or a heart attack. I'm going to put HA again for heart attack within 1 year on this second drug. We'll call it drug T. And so what we wanted to see here again is that it's less for those taking the second drug. So our null will be a statement of equality. So P sub 1 is equal to P sub 2. And our alternative will be, it's greater. It's greater for those taking that first drug. So alpha is equal to 0.01 here. Test statistic and p-value, the calculator is going to give us real quickly. Okay? So let me go back to the previous slide. And we'll start plugging in the information. Stat tests, 2-prop z test. Here it was 668 experienced a heart attack in the first year out of 6676. The second one, it was 569 had the heart attack in the first year out of 6732. And what we wanted to test, make sure you get your alternative set up correctly, was that P1 is greater than P2. Wow, look at this. Here's my test statistic. It's 3.1086. And so my p-value, again, remember from our previous video what this e to the minus 4 means? Move the decimal point to the left 4 spaces. So it's 0.00094 when I round it. So look, even though these proportions, only 1.5 percentage points off from each other, really, the large sample size tells us, yeah, there's a difference. So we're going to reject the null. All right, the p-value is less than alpha. And evidence does suggest those taking drug T have, in terms of a proportion, less stroke or heart attack in first year than those on drug C. They're less likely. Let me change that up just so I get that correct. All right, class, these are pretty straightforward once you have the numbers to set up and jump right into it. But, as always, if you have any questions, let me know.